Hello students, in this class we shall be discussing some important questions from measures of central tendency and dispersion, and these questions have been asked in the previous exams and these are based on the memory of previous students, and we shall be covering about 100 questions in this session, in this series, and we will be taking 10 questions per video. Okay, so let us begin. First question. Consider the first question. If x and y are related by x minus y minus 10 equal to 0 and the mode of x is known to you as 23, then find the mode of y. It is 20, 13, 3 or 23. Okay, we know that how mode is related. Mode is, the observations are related in this way. Okay, x minus y minus 10 equal to 0. We have x minus y minus 10 equal to 0. So y can be written as x minus 10. So we already know that mode of y can be written as mode of x minus 10, because we know that if y is equal to a plus bx, then mode of y will be equal to a plus b, that is b into mode of x. Okay, so mode is affected by change in scale and origin, in the same way. Okay, so therefore what we have, mode of x is given to be as 23. So we have 23 here minus 10, and that is equal to 13. So our answer is 13. Option B is your answer. Now let us look at the second question. Second question is, a man travels at a speed of 20 kilometers per hour and then returns at a speed of 30 kilometers per hour. His average speed of the whole journey is which of the following? Okay, let us look at the problem. Here, so this is to find average speed. Okay, so whenever we need to find out average speed, we will be using harmonic mean. Okay, harmonic mean is used to find out average speed of whole journey. So suppose here in this case we have two different speeds. One is 20 kilometers per hour and the other one is 30 kilometers per hour. First one is A, the other one is B. Assume. Okay, so we have, say, A is equal to 20 kilometers per hour and B is equal to 30 kilometers per hour. So average speed, okay, average speed is equal to harmonic mean of A and B. So we know that harmonic mean of two observations is given by 2 times AB divided by A plus B. Okay, so what we have here is 2 into 20 into 30 divided by 20 plus 30. Okay, so when we calculate this thing, we will get 24 kilometers. Okay, it is 24 kilometers per hour. Okay, so option C is your answer. Option C is your correct option. Okay, next question. A student obtained the mean and standard deviation of 100 observations as 40 and 5.1 respectively. The mean of n observations, here n is equal to 100. Okay, the mean here is given as 40 and the standard deviation is 5.1. Okay, so here later he discovered that he had wrongly copied down an observation as 50 instead of 40. So therefore this is wrong mean and this is wrong standard deviation. Okay, we need to find out the corrected standard deviation. Okay, so how to find this? Okay, so here we have the wrong mean. Wrong mean is 40. This is the wrong mean, wrong x bar or wrong mean, and that is equal to 40, and we have wrong SD, wrong standard deviation, wrong SD, and that is equal to 5.1. Okay, now here the correct observation, he had wrongly copied down an observation as 50 instead of 40. So 40 is the correct observation and 50 is the incorrect observation. So correct observation is equal to 40 and wrong observation is equal to 50. Okay, this is what is given to us. We need to find out the correct standard deviation. We need to find out the correct standard deviation of this data after making some corrections. Okay, so let us start doing the problem. So first thing, we need to correct the sum. Okay, find the correct mean. So to find that, we need to, what we have is wrong sum. Wrong sum will be equal to wrong mean. Okay, wrong mean into number of observation. Okay, wrong sum will be equal to wrong mean into number of observations. So this will give you 40. This will be equal to, say, 40. Wrong mean is 40 into number of observations is 100. So into 100. Okay, so what we have here is 4000. Okay, now the correct sum. We need to first of all find the corrected sum. Corrected sum will be equal to wrong sum minus, we remove the wrong observation and put in the correct observation to find the correct sum. Okay, that is equal to wrong observation plus the correct observation. Okay, so what we get here is wrong sum is 4000 minus wrong observation was 50 minus 50 plus correct observation is 40. So we have 40 here. So that the final answer will be 3990. Okay, this is the corrected sum. Now the correct mean. Okay, correct mean. How to find the correct mean? Correct mean will be equal to correct sum divided by total number of observations, and that is equal to 3990 divided by 100, which is equal to 39.90. This is the correct mean, that is equal to x bar. Okay, now we need to find out the corrected standard deviation. So to find the correct standard deviation, we need to correct many things. Okay, so what is the formula to find the standard deviation? The formula to find standard deviation is, look here, formula will be like this. Okay, so this is a SD will be equal to square root of this is sigma xi square divided by n into, minus sigma xi by n whole square. Okay, this is the mean. Okay, this is the mean, and this is corrected sum of squares. So this has been corrected. But this part has not been corrected. So this is the wrong part. Okay, so from whatever we have, we need to correct this. Okay, so the square of standard deviation will be equal to this without the root. Okay, so that is what we are going to do. So let us find out. SD square will be equal to or it is variance. SD square will be equal to sum of this is wrong sum of squares. This is wrong sum of squares divided by n. Okay, this is wrong sum of squares divided by n minus the wrong mean whole square. Okay, that is wrong mean whole square. Wrong mean whole square. Okay, so we shall now put the values as SD square will be equal to, what is SD square? SD was given as, wrong SD was given as 5.1. So it is 5.1 whole square, 5.1 whole square will be equal to 1 by 100 into corrected sum. Okay, 1 by 100 into wrong, 1 by 100 into wrong sum of squares. What is wrong sum of squares? Wrong sum of squares will be, is not known to us, is wrong sum of squares, okay, minus wrong mean. Wrong mean, what is the wrong mean? Wrong mean is 40. 40 square is 4 4 the 16, or we can write it as 40 whole square right now. Now next thing is we need to calculate the values. How to calculate this? So this is 5.1 whole square. What is 5.1 whole square? 5.1 whole square is 26.01. That is equal to 1 by 100, 1 by 100 into wrong sum of squares, wrong sum of squares, minus 4 4 is 1600. Okay, so when you calculate this, so we get the wrong sum of squares, okay, will be equal to, okay, 1600, 1600. So when you take this that side, it becomes plus and added to 26.01, so it becomes 26.01 into 100, okay, into 100, which will be equal to 162601. Okay, wrong sum of squares will be equal to 162601. Now what are we supposed to do? Now we need to find out the correct sum of squares. Okay, how to find out the correct sum of squares? So correct sum of squares. We have found out the wrong part. Correct. We need to correct this. So how to correct this? So the sum will be equal to, the correct sum of squares will be equal to wrong sum of squares, sum of squares, wrong sum of squares, minus square of the wrong observation whole square, plus correct observation whole square, correct observation whole square. Okay, so what we get here? We get here the wrong sum of squares is 162601. So we get 162601 minus, what is wrong observation? Wrong observation was with us. Wrong observation was, let me see, where is the wrong observation? We have the wrong observation as 50. We have the wrong observation as 50. So we have 50 square, that 2500 plus correct observation whole square. Correct observation was 40. So 4 4 is 16, 1600. Okay, so when you calculate this, we get 161701. Okay, now we can correct the variance. So we have the standard deviation square. So we have the correct variance or corrected variance. Let us now correct the variance. So corrected variance or correct variance will be equal to correct sum of squares, correct sum of squares divided by n minus correct mean whole square. Okay, minus correct mean whole square. So how can we do this? So we can put the values, and that is equal to 161701, which is the corrected sum of squares. As we have found here, the corrected sum of squares is 161701 divided by total number of observations, that is 100, minus correct mean. Correct mean was 39.90, into the whole square. Okay, and that is equal to 1617.01 minus the square of 39.9 is equal to 1592.01. Okay, and this will give you 25. Okay, correct variance is equal to 25. So therefore correct standard deviation will be equal to 5. So correct standard deviation will be equal to 5. So what is the process? Let us discuss the whole problem again. What was given to us? It was given that there was n observations. We had n observations, n is equal to 100, and the wrong mean was 40 and the wrong standard deviation was 5.1. Okay, we have the correct observation as 40 and the wrong observations as 50 because it was taken as 50 instead of 40. So this is the correct observation and this is the wrong observation. Now we know that mean is equal to, how to find the mean? Mean will be equal to sum of observations divided by number of observations. Therefore the sum will be equal to n into the mean. Okay, so therefore what happens is wrong sum is equal to wrong mean into number of observations. Number of observations is correct. So therefore what we have is wrong mean into n. Okay, sum will be equal to mean times the number of observations. So therefore what we have is 40 into 100, which is equal to 4000. So this is the wrong sum of observations. Now to correct the sum, we remove from the wrong sum the wrong observation and then add in the correct observation. So when we do that, we get 3990. We get 3990 as the corrected observation. Corrected sum. So now we shall find out the correct mean. How to find the correct mean? We just use the same formula, but we put the correct values. That is, correct mean will be equal to the correct mean will be equal to the correct sum divided by the number of observations. That is, correct sum divided by n, and that is equal to 3990, which we have found here, divided by 100. Okay, that is equal to 39.90. This is what we have as the correct mean. Okay, one of the values. Next, we know that the standard deviation is defined as the square root of sum of squares. Sum of squares of observations divided by n minus the mean of observations, the square of mean of observations. Okay, so therefore what we have here is the variance will be equal to the square of this. So variance is standard deviation whole square. So we take square on both sides, we get the standard deviation square as the variance. Okay, variance is equal to SD square, which is equal to wrong sum of squares divided by n minus the wrong mean whole square. Okay, so it is this. Now we put the values. The wrong standard deviation was given to you. The wrong standard deviation was given to you as 5.1. This is the wrong variance. Wrong variance, we use the wrong standard deviation. Okay, wrong standard deviation. Wrong standard deviation will be equal to the wrong sum of squares divided by n minus the wrong mean. Okay, so 5.1 the whole square will be equal to 1 by 100 into the wrong sum of, just put the value of n here, and minus 40 whole square. Wrong mean was 40. Okay, so you get 40 square, that is 1600. So calculating this, we get the wrong sum of squares as 162601. Okay, now we need to correct the sum of squares. So now we have the wrong sum of squares. So from the wrong sum of squares, we remove the square of the, please be careful, we remove the square of the wrong observation and add the square of the correct observation. Okay, we remove the wrong observation square and then add the correct observation square. Okay, so finally we calculate and get 161701. This is a very important and lengthy problem. We need to be careful while dealing with such problems. Okay, so now we shall find the correct variance because we have all the correct values for this formula. This is correct sum of squares. That is sigma xi square is called correct sum of squares divided by n minus, see, correct mean is sum of xi divided by n or x bar whole square. Okay, This is what we define as the variance. Variance is sigma square is variance or the correct variance. It is, so we call it the sum of squares. So corrected sum of squares divided by n minus correct mean the whole square, and what we get here is 161701 divided by 100 minus 39.90, as we have already found out the correct values, and we are just putting in those correct values, and finally get 25 as the correct variance. And what we have been asked to find is the correct standard deviation. So the corrected standard deviation here in this case is 5. Okay, so our option is option A is your correct answer. Option A, 5 is your correct answer. Okay, next problem. For a moderately skewed distribution, the quartile deviation and the standard deviation are related by which of the following relations? We have discussed in the properties of standard deviation that standard deviation will be equal to 3 by 2 times quartile deviation. Okay, so option D is the correct answer, or 2 times standard deviation is equal to 3 times quartile deviation, or standard deviation is equal to 1.5 times quartile deviation. This is what you should know. Okay, so that is D. The result is derived from the normal distribution concepts, which we shall be taking further later on. Okay, question number 5. Find the median of the following data. How to find the median? This is ungrouped data, so we need to first of all arrange all of them in a proper order, ascending order or descending order. We shall arrange it in ascending order. So let us arrange them in ascending order. So 2, then 4, then 6, then 8, then 11, and then we have 13, and then 15 and 18. Okay, we have arranged all of them in an ascending order. Now median is the centrally located value. Now here 1, 2, 3, 4, 5, 6, 7, 8. So here n is equal to 8. So we have 2 middle observations. Okay, 2 middlemost observations. Here clearly we can see that 8 and 11 are the centrally located observations. So we need to find out the arithmetic mean of 8 and 11. That is equal to 8 plus 11 divided by 2, and that is our median. Okay. Okay, what is 8 plus 11 is 19 divided by 2. 9 2s are 18. So it is 9.5. Okay, we have 9.5 as the median. Where is 9.5? 9.5. Option D is your correct answer. Next question. Sum of squares of deviations of a set of observations has the smallest value when the deviations are taken from which of the following values? Okay, we have studied in the properties of arithmetic mean that the sum of squares of deviations taken from the arithmetic mean is minimum. Sum of squares of deviations taken from the arithmetic mean is minimum. Okay, sigma xi minus x bar whole square less than or equal to any other value. If you take any other value as the assumed mean, sum of squares of deviations taken from the arithmetic mean is minimum. So we have A as the correct answer. Next question. Question number 7. If two sample sizes of 30 and 20 have means as 50 and 60 respectively, and variances as 16 and 25 respectively, what would be the standard deviation of the combined sample size? Okay, here we need to find out the combined standard deviation. Okay, the formulas are like this. Okay, if there are two groups, n1 and n2 observations, okay, then, and having x1 bar and x2 bar as their respective means, then, and S1 bar and S2 bar, S1 and S2 as the respective standard deviations, then the combined standard deviation will be given by combined standard deviation is equal to square root of n1 into S1 square plus n2 into S2 square plus n1 into D1 square plus n2 into D2 square. Okay, divided by n1 plus n2. Here what is D1 and what is D2? They are deviations of the given means, of individual means from their combined means, where x bar is the combined mean. We need to find out the combined mean also. So that is what we need to find out first. So first let us do the calculations. We need to find the combined mean first of all. So first find the combined mean. That is, here n1 is equal to 30 and n2 is equal to 20. Okay, then we have x bar, x1 bar equal to 55 and x2 bar equal to 60. Okay, now their variance is S1 will be equal to, S1 square will be equal to 16 and S2 square is given to you as 25. Okay, because variances are given, not standard deviations. Variance means S1 square and S2 square. Okay, now we have the combined mean. Okay, combined mean. How to find the combined mean? Formula is N1 into x1 bar plus n2 into x2 bar divided by n1 plus n2. Okay, so when we put the values, what we get for the values, we get 30 into 55 plus n2 into x2, 20 into 60, that is 20 into 60 divided by 30 plus 20. Calculating this, we get 57. Okay, after calculating, we get 57 as the combined mean. Okay, this is the combined mean, 57. Okay, this is equal to 57. Now we shall find out D1 and D2. Okay, how to find out D1? Now we need to find out D1. What is D1? D1 is x1 bar minus x bar. What is x bar? X bar is the combined mean. X bar is equal to 57 is the combined mean. So we have 55 minus 57. And what is D2? D2 is equal to x2 bar minus x bar, and that is equal to 60 minus, this is 60 minus 57. So here 55 minus 57 is minus of 2 and 60 minus 57 is 3. Okay, now to find the combined standard deviation, what we have is to find the combined standard deviation. Formula is given as n1 into s1 square plus n2 into s2 square plus n1 into d1 square plus n2 into d2 square divided by n1 plus n2. Okay, combined standard deviation, and then the square root. Then the square root of this value. So we can put the values. So when we put the values, we get it is as 30 into 16. 16 is s1 square. S1 square is 16 plus n2. n2 is 20 into 25. That is 20 into 25 plus 30 into d1 square. d1 square is 4 minus 2 whole square is 4. Then 20 into d2 square. d2 square is 3 3s are 9. Then whole divided by n1 plus n2. What is n1 plus n2? It is 50 or 30 plus 20. And when we calculate this, we get 16 3s are 48. So 48 0 plus 12 25 2s are 50 plus 4 3s are 12 plus 9 2s are 80 divided by 50. Okay, we need to put the square root also. We need to put the square root everywhere. So it is better to have square here and then put the square root later on for simplification. Now when you do the calculations, what you get here is this is 25.6. Okay, it is 25.6. And we get 25 square root of 25.6 in the calculator. What we get is 5.06. Okay, 5.06. This is your combined standard deviation. Combined Standard deviation is 5.06. Let us see whether it is in the answers. 5.06. Yes, we have 5.06. Option C is your correct answer. Okay, this is a very important question to find out combined mean of a standard deviation, combined mean and combined standard deviation of two different groups of observations. Now let us go for the next problem, question number 8. If two variables x and y are related to each other in this way and the mean and mean deviation about the mean of x are given to you. Okay, what we have here is x and y are related to each other as x plus, okay, x plus 3y minus 7 equal to 0. Okay, x plus 3y minus 7 equal to 0. Then what we have is how to calculate this, and what else we have? The mean and the mean deviation. Mean is x bar is equal to 1, and mean deviation md about x bar will be equal to 0.3. Then the coefficient of mean deviation about the mean of y will be equal to what? That is what we need to find out. Coefficient of mean deviation. We need to find out coefficient of mean deviation about y bar. So for that we need to find out mean deviation about y bar, mean of y and everything. Okay, so first thing, let us convert this thing into y form. Y will be equal to 7 minus x divided by 3. So by 3 by 3. Okay, this is the relation given to us. So we have y is equal to 7 by 3 minus x by 3. So this a is equal to minus 7 by 3 and b is equal to this. So what is y bar? Y bar is equal to 7 by 3 minus x bar by 3. Okay, x bar by 3. We know this. So what is 7 by 3? 7 by 3. 7 minus x bar. What is x bar? X bar is given to you as 1. So 7 by 3 minus 1 by 3, and that is equal to 6 by 3, which is equal to 2. Okay, so we have y bar as 2. 2 is equal to y bar. We have the mean of y. Now, what is the formula to find coefficient of mean deviation of y? Mean deviation of y bar, from y bar divided by y bar. This is what we need to into 100. Okay, this is what we need to find out. We need to find both y bar as well as mean deviation about y bar. Now, what is mean deviation about y bar? Mean deviation about y bar will be equal. It is dependent on d, change in scale, not origin. So modulus of b into mean deviation about x bar. Okay, this is into this. So what we get here is, what is modulus of b? Here b is equal to 1 by 3. Sorry, b is equal to minus 1 by 3. So it is 1 by 3 into mean deviation of x bar. Okay, so here b is equal to 1 by 3 minus 1 by 3. This is what we need to keep it from here. So modulus becomes 1 by 3 into mean deviation of x bar, which is given to you as 0.3. Okay, so that is equal to 0.1. 0.1. Mean deviation about y is 0.1. Okay, now coefficient of mean deviation about y is given as this formula. So what we have here is 0.1 into 100 divided by the mean of y, that is equal to 2. Okay, 1 into this is 10 divided by 2, which will give you 5 as the mean deviation, coefficient of mean deviation about the mean of y. So we have found out the coefficient of mean deviation of y about its mean. So answer is 5. Option A, 5 is the correct answer. Now we shall move on to the next problem, question number 9. Which of the following results hold for the set of distinct positive observations? See, mark the words distinct positive observations. So the observations are distinct and they are positive also. We have studied that AM is greater than or equal to GM is greater than or equal to HM always. But Equality holds. Equality holds only if all observations are equal. Okay, so therefore here we have distinct positive observations. So therefore option D will be the correct answer. The equality will not hold. Equality will not hold in this case always. So the most appropriate answer is AM greater than GM greater than HM. You can observe the remaining one. They are not. This is not correct. This is not correct. This seems to be correct, or this seems to be correct. But the most appropriate one is this, because we have distinct positive observations. Okay, next question. The question number 10. The measures of dispersion are what type of, means are averages of dash order. Okay, so we know that we have discussed in the introduction part of dispersion that measures of dispersion are called averages of the second order. Okay, averages of the second order. Option B is the correct answer. Option B is the correct answer.